Okay. Believe we are live again. Just gonna work a few things out here so that we can be sure that this is working okay. Of course, nothing could work correctly the first time. Why would it? Okay, I'm going to post an updated link here. Sorry for the typing sounds. We're getting there. Okay. I can see there's at least a few viewers. If anyone is currently watching, if you could just send a message in chat, that would be useful. Okay, I see the number jumped up to 5. That's good, that's a plus. Just want to make sure audio is coming through here. I think it is. You hear the clicking on the keyboard. Okay, that's... Alright. Well, that means that audio is coming through, so that's a good thing. Alright, well, hopefully some more people join in as we go here. But I think the time has come. So let me make sure this is focused. So, welcome to our Regents Review live stream. I would assume you know this, but you know, it's me, Mr. Diodonato, the one and only. So what we've got here is the August 16th, 2022 Regents Exam. This was issued in August of 2022, so just under a year ago. And we're going to go through it. I'm going to go through every single question. I'm going to explain my responses to every question. I'm not just going to blow through it. And if at any point during the test you have any questions about where I got a solution, or if you just want me to re-explain something, I would be more than happy to do so. Just throw it in the chat and I will do just that. So, without further ado, I have my pen, because for Regents exams you can't write your answers in pencils unless it's a graph. And I have my calculator, just like the one that you are going to have on this test. So we're going to take full advantage of that. So I'm going to start off by writing my name, and yes, I'm going to write my full name. Christopher Diodonato. That is my name. And you will fill in your name just like that. And for school name, of course, you are going to put Liberty High School. Okay. Now, you will get a chance to read everything on the front here, but I am going to just emphasize what we've got here. Your phones and your AirPods and your smartwatches and literally any electronic device that you have. You cannot have it on you during the Regents exam, and if they find one on you, or if they even just see something in your pocket and it turns out to be something as simple as an AirPods case, they will invalidate your score, and that is not a joke. If you are caught with that, you straight up will not get any credit for this exam, no matter how good you do on it. So please do not take that risk. Just either leave your devices at home or leave them with someone at the school on the day of the test. All right, so we're going to start with the part 1 questions, which is going to be 24 multiple choice questions, and then we're going to go on to the parts 2, 3, and 4 questions, which are all going to be short response. So without further ado, we're going to open up the test and we're going to get started here. And just worth noting, I have not looked at this test beforehand. I just grabbed it, and I'm going in just as blind as you would be going into your Regents exam. Now, some of these questions might end up looking familiar because we've done them for review, but, you know, most of them are going to be new to you. All right, let's begin. So our first question here. If f of x is equal to 3x plus 4 all over 2, then f of 8 is one of these. So this is a classic plugging into a function question. So whenever you have something like f of 8 and you want to find the value of that, you take whatever the function is, in this case f of x, and you just replace the x with 8. So let's do that. We're going to rewrite this. F of 8 is equal to 3, and then instead of x, we're going to write 8 plus 4, all divided by 2. And you absolutely could just simplify that by hand, but again, we have the power of technology on our side, so we might as well use it. So we're going to go to our scratch pad here. I don't know where all that came from. And we're just going to type that in. We're going to make a fraction. So we do control. Let me position this. Control, and then the division sign. That gives us a fraction. So we have 3, parentheses 8, plus 4. We can go down, divided by 2, we hit enter, and we get 14. And wouldn't you know it, 14 is an answer choice. So that's going to be our answer. Let me actually write that there. Now, one thing here that is not accurate to the actual test is that there will be a separate answer sheet. So like a bubble sheet for you to choose your answers. You can circle them on the test, but it is very important that you also fill it in on the bubble sheet itself. In addition, you have to use a pen. Can't use pencil on the Regents exam. The only place you can use pencil is when you're doing graphs. But we're going to stick with our pen. All right, let's move on to question 2. If x does not equal 0, then the common ratio of the sequence x, 2x squared, 4x to the power of 3, 8x to the power of 4, 16x to the power of 5, and continuing ... is. So before we move on, I think I'm going to move the camera down a little bit here so we can just see better. There we go, that's better. All right. So common ratio. That is a term that shows up when we are talking about sequences, specifically geometric sequences. So a geometric sequence is calculated by multiplying the first term by the same thing every time. So you start with x, we multiply it by something to get to 2x squared. We multiply that by the same exact thing, and we get 4x to the power of 3. So it's basically the string of multiplication every single time. And the big question is, well, what are we multiplying by? And a surefire way to figure that out, even if you might notice it, right off the bat, but what you can do is if you take one term and divide it by the previous one, it will give you the common ratio. So I'm actually going to pick 4x to the power of 3, and I'm going to divide it by 2x squared, or 2x to the power of 2. So we're going to do 4x to the power of 3 divided by 2x to the power of 2. Now, this is where we need to remember our exponent rules. So this is where the quotient rule would come into play. So the first thing we want to do is just deal with our coefficients. 4 divided by 2. 4 divided by 2. You could put that in the calculator, but I'm just going to go ahead and say that is 2. And then x to the power of 3 divided by x to the power of 2. Now, the rule to remember here, like I said, is the quotient rule, which says that if you are dividing exponents like that, you take the powers and you subtract them. So we would do 3 minus 2. So that would give us x to the power of 1, because 3 minus 2 is 1. But, as we know, when we have something to the power of 1, we don't actually have to write that 1. So this is really just 2x. And lucky for us, that's an answer choice. Choice 1. So the answer to this question, the common ratio of this sequence, is 2x. And you can confirm that by multiplying x by 2x. That does give you 2x squared. Multiply by 2x again, we get 4x to the power of 3, and so on. All right, and that's question 2. Again, if you have questions at any point, please say something in the chat, and I'd be happy to go back and answer them. All right. The expression 36x squared minus 9 is equivalent to one of these. So this is a classic factoring problem. Just like we did in class today, we did some factoring, but this is a special kind of factoring like we did last week. This is a difference of perfect squares type of factoring. So difference of perfect squares just means we have something that is a perfect square, basically something that has been squared already, minus another perfect square. We can tell because 36 is a perfect square, it's 6 times 6, and 9 is a perfect square, it's 3 times 3. And that pesky x squared in there, well, it's squared, so that's how we can tell that it's a perfect square. So when we do difference of perfect squares, that's when we set up our two parentheses, and we already know that it's going to be a plus and a minus, both just from how difference of perfect squares works, and our constant term is negative. And as we've seen, when the constant term is negative, you always have a plus and a minus. So now we need to ask ourselves, well, let's start with 36x squared. What times itself is 36x squared? Now, the x part of that might be a little easier to figure out. It's just x, because x times x is x squared. So we know there's going to be an x here. So we can start there at the very least. But the 36, now, if you've memorized your first couple perfect squares, that's great. But if you have forgotten exactly what the square root of 36 is, again, calculator comes to the rescue here. So let's just do it in here. So if you want to take the square root of something, you hit Control, and then you hit the x squared button, because you can see the square root symbol right above that. So we're going to hit that, and then we just put in 36. And we get 6. So we know the first couple terms here are going to be 6x, which technically kind of narrows us down to only one option already, but we might as well finish this. Now we just need the square root of 9, which, if you put that into your calculator, just like 36, you would see that the square root of 9 is 3. So we do 3 and 3. And I know it's a little bit hard to see on the camera, but that is 6x plus 3 times 6x minus 3. That's exactly what we should have ended up with. So the correct answer choice is choice number 3. And that's how we factor with difference of perfect squares. Okay, let's move on to question 4. Excuse me, I need to take a sip of water. Okay. So, number 4, given the relation R is equal to, and it looks like we have some ordered pairs here. I'm going to move this down again. There we go, that's nice and clear. So we've got a bunch of ordered pairs here. Now, big thing to remember, when you have a pair like this, where it's in parentheses, a number, comma, another number, those pairs are x, comma, y. Now, when we are asking about whether something is or isn't a function, the big rule to remember is that it's one input, one output. Basically, one input cannot give you more than one output. Now, it's also important to remember that our inputs are our x, also known as our domain. And our outputs are our y values, or our range. So, all we need to do is make sure that none of these x values repeat, because that would mean that one input gave us multiple outputs. So, let's check all of these options. Can -4 replace x? Well, we already have -4 as an x value. So, if we put -4 again, this wouldn't be a function. So it can't be -4. How about -1? Well, if we check the inputs we already have, -1 is already an input with an output of 4. So if we made -1 an input here with an output of 8, this wouldn't be a function. So it can't be -1. We'll check the same thing for 3. Well, again, 3 is already an input. That would make this not a function. So we're only left with one choice, 0, and wouldn't you know it, 0 doesn't show up as an input already. So 0 would absolutely make this relation a function if we replaced x with it. So choice 4 is our answer here. All right. Function questions are pretty common, so definitely worth, considering and watching out for. All right. Let's move on to number 5. If the point k, -5, lies on the line whose equation is 3x plus y equals 7, then the value of k is, well, one of these. So this actually is not as different from number 4 as you might think. Remember, when we have an ordered pair like this, what do those numbers represent? Same thing as up here. X and Y. I can already see I've gotten blue ink on my hand. That's great. So we've got this equation here. 3x plus y equals 7. Well, we were just given an x and a y. We were just given an ordered pair. And our goal is to figure out what k is. So let's rewrite this equation, but let's replace x with k and y with -5. Let's see what happens. So 3, and instead of x, I'm going to write k. Plus, and instead of y, I'm going to write -5, and I'm going to put it in parentheses because we like to be careful with negative numbers, equals 7. And this turns out to just be a pretty straightforward equation for us to solve. We're going to drop our line through the equal sign. And first thing, let's simplify this a little bit, because adding a negative number doesn't really look too pretty, and it's probably just going to confuse you. So 3k stays the same, but what actually is, what happens when you add -5? Well, that's the same thing as just subtracting 5. So we have 3k minus 5 equals 7. And now we just use our inverse operations. So we start with addition and subtraction, and we're subtracting 5, so let's add 5 to both sides. That cancels out. We get 3k is equal to 7 plus 5, that is 12. And then we have 3k is equal to 12. So we divide both sides by 3, because 3k means 3 times k, and the opposite of multiplication is division. And just so I don't encroach upon the space of this next question too much, I'm going to go off to the side here. Make sure that 2 is visible. And we get k is equal to, well, what's 12 divided by 3? That is 4. So k equals 4 is our solution here. And hey, look at that. It's actually choice number 4. Love when that happens. And there you go. K is equal to 4 in this situation. All right. We got one more question on this page. We're making great progress here. So, we've definitely done this question in class. The expression 1/3 x, or 1 over 3x, times 6x squared minus 3x plus 9 is equivalent to one of these 4. Well, whenever we have something multiplied on the outside of parentheses like this, there's one particular property of numbers that we like to use, and that is the distributive property. I'm going to just write that here. And that says that if you have a number multiplied like this on the outside of parentheses with multiple terms inside, you can distribute that multiplication. Basically, that one thing on the outside gets multiplied by all 3 things on the inside. So, let's do some multiplication. 1/3 x times 6x to the power of 3. Well, we have 2 things to deal with. We have to do that 1/3 times 6, and we have to do x times x squared. So let's start with the 1/3 and 6. Now, again, there's not too much we can do here other than just either do the math or just throw it in the calculator. And if you're not sure about multiplying fractions and stuff, just throw it in the calculator. There's no harm. So we're going to do control, and we're going to hit our division sign because that gives us a fraction. We're going to do 1 over 3, and we're going to multiply that by 6. Okay, that gives us 2. So we can, we'll write it over here, equals 2. And then x times x squared, or x times x to the power of 2. And before we did the quotient rule, where you divide exponents, you subtract them. But when you multiply them, you add them together. So remember, whenever you have just x, there's an invisible 1 there. So x to the 1 times x to the 2 would just give us x to the power of 1 plus 2, which is 3. And right there, we can already eliminate 2 answer choices. We can eliminate choices 1 and 2 because neither of those choices have that x to the power of 3. So it can't be either of those. So now we just need to narrow it down to these last 2. And to do that, we'll just distribute again. We'll multiply. So this time we have 1 over 3 times negative 3. Now this is an important property of fractions and stuff. If I have something like this, 1 over 3 times, well, it's negative 3 in this case, so it's going to be negative. If you multiply a number by the same thing you're dividing by, it just turns into 1. So 1 over 3 times negative 3 is actually just negative 1. And x to the 1 times another x to the 1. We add 1 plus 1, and we get x to the power of 2. Now, important thing to note here, whenever we have a 1 as a coefficient like that, you don't technically need to write it. It can just disappear because it means the same thing. So if we just saw a negative x squared, that would be our giveaway. And if we look at our answer choices, well, answer choice 4 has 3x squared. That's not right. So it must be option 3. And just so we can, whoa, I don't know what that is. Just because we can, let's just finish our distribution here. 1/3 x squared, no, 1/3 times just x times 9. Well, 1/3 times 9 gives us 3. So that comes out to 3, and then there's no other x's here, so it's just x. And that's it. We've distributed and we found which one is equivalent. Alright. It's finally time for us to turn the page. It's very exciting, I know. Oh boy, we've got graphs. Alright. Again, I have not taken this test yet, so I'm going in completely blind. So, number 7. The graphs below represent 4 polynomial functions. Which of these functions has zeros of 2 and negative 3? So in order to answer this question, or in order for us to answer this question, we need to remind ourselves, well, what is a zero? What does that mean? And we actually went over this in class today, so this is a good question for us to do. The zeros of a function, let's say f of x, are just the x values where the function equals 0. So all we need to do is check each of these graphs and see which ones have, x values of 2 and negative 3 when the function is equal to 0. But I could understand the confusion, or it's like, what do you mean it equals 0? Well, as we've discussed, the input of a function is the x values, but the output is the y value. So all you need to check is where is the y value equal to 0? And luckily there's a nice visual cue for that. It's when you're right along the x-axis, when it crosses the x-axis. So all we need to do is check which one of these crosses the x-axis when x equals 2 and x equals negative 3. So let's test them out. So number 1, well, here's a 0 and here's a 0. Well, what is x equal to at that point? Well, if we go from the center, we go to the left, 1, 2. So if we're going to the left by 2, that means x equals negative 2. That's not one of the values that we're looking for here, which means it can't be choice 1. Let's check choice 2. Same thing. We've got a 0 here and a 0 here. They're really close to each other this time. This first one looks like the same one as up there. It's 2 to the left. X equals negative 2, which, again, that's not one of the values we're looking for. So choice 2 also can't be correct. Let's try choice 3. Let's start off by identifying the zeros. Again, we've got one here, and we've got one here. This first one, 1, 2, 3 to the left, which means that it's x equals -3, which that's a good sign. That's one of the ones we're looking for. But we can't conclude that that's the right answer yet, because we have to make sure the other one is 2. So that's the second one. We go 1, 2 to the right, which means it's x equals 2. And therefore, we've got the correct zeros, just what they asked for. So it's got to be choice 3. And if you looked at choice 4, you could see that it has one of the right zeros. It does have x equals 2, but then it has x equals 3 instead of -3 like we were looking for. So that can't be it either. And we've identified our zeros. So let's move on to question 8. What is the constant term of the polynomial 4d plus 6 plus 3d squared? So we need to remind ourselves, what does constant mean? And if you just think of that word, when you think of something constant, you think of something that's unchanging. It doesn't change. It's the same thing all the time. And in math terms, it means pretty much the same thing, but it just means there's no variable attached to it, no letter attached to it. So if we look at this polynomial here, we just need to find which number isn't attached to a variable. And clearly it's not 4, because that's attached to our letter D here. So we already know it's not choice 4. We also know it can't be 3, because 3 is attached to D squared. So that's not it either. And really all we're left with is this 6. This 6 is not attached to a variable, it's just by itself. So that's our constant term. Now, we just check our last options here. 6 is an option, and it's the correct one. So again, if you're looking for the constant term, you're just looking for whatever number is not attached to a variable. That's it. Excuse me. All right. Let's keep chugging along here. Oh boy, a word problem. I know we love those. So, Emily was given $600 for her high school graduation. She invested it in an account that earns 2.4% interest per year. If she does not make any deposits or withdrawals, which expression can be used to determine the amount of money that will be in the account after 4 years? Okay. So we're dealing with a particular type of growth, and the giveaway here should be 2.4%. As we went over last week, whenever you see percent, like percent growth or percent interest, that is exponential growth. Or it could be decay, but in this case, she's earning 2.4%, so it's going to be growth. Now, we can kind of already tell that based on, all of these options have an exponent in it, which makes sense. So we just need to determine which of these is correct, which one of these properly models the situation. So the first part of that can actually be answered by what we said before. She earns interest. And if you're earning interest, that means you're gaining money. You're not losing it. It's not going down. So that's the first sign we can check for. If they're going to be gaining interest, that means there's going to be growth. There's going to be positive. There's going to be a plus in our parentheses here. So choices 2 and 4 have subtraction. Those would be exponential decay. So it's definitely not going to be 2 or 4. So we just need to decide between choices 1 and 3. And the only differences between those two options are choice 1 has 1 plus 0.24, and choice 3 has 1 plus 0.024. So that really just comes down to how we figure out percents. So whenever you want to write a percent as a decimal, which is what we're trying to do here, there's two ways to think about it. You can either move the decimal place over twice to the left, and any blank spots, you just add another 0. Or you can just take the number and divide it by 100. In either case, you're going to get the same thing. So let's demonstrate it. Why not? So we'll do 2.4. Hold on, something on my screen messed up. 2.4 divided by 100. And if you want it as a decimal, you hit Control and then Enter. And we get 0.24. God, that is blurry. There we go, 0.024. So we know now, we know now that 0.024 is the decimal we're looking for. And if we compare our two options, looks like choice 3 is the one we're looking for. So choice 3 is the correct answer here. All right. Look at that. We're already 2 pages in. Now, as you can see, I've been kind of taking my time on these. I'm definitely not blowing through these questions. And just as a reminder, you get 3 hours for this test. Take advantage of it. Take your time. Really think about each of these questions. All right. Turn the page here, and we're going to keep going. All right. We have another question that we did in class. Look at that. So we've got a couple different ways of representing some data here. We've got a dot plot. We've got a box plot, or a box and whiskers plot, if you prefer to call it that. And we have a histogram. So the question here is asking us, which data representations have a median of 2? So this is back to our statistics unit. I know we went pretty fast through this one, but we did go over this. So let's check it out. I think we should start with our box plot, because that one, it pretty clearly tells you what each of the things on it are. So just as a reminder, the first line, the one all the way to the left, is your minimum. The first line on the box is Q1, or your first quartile. This middle one, the one that's in the middle of the box, that's your median. The one on the end of the box is Q3, or your third quartile. And then this last one is your max, your maximum. So we can pretty easily check what is the median of this set of data. Well, we look at this center line here, and it's 2. So that one is correct. It does have a median of 2. Now, of course, we still need to check the other 2, but just based on that, we can still eliminate an answer choice here. We can eliminate choice 2, because choice 2 says that only 1 and 3 have medians of 2. But we just showed that the second one also does. So that can't be our answer. So now let's test out number 1. So this time we have a dot plot. Now this is going to be a little bit more involved, and again, you can do this on the calculator, and I will show you how, because I think it's important that we know. So as a reminder of how to read a dot plot like this, what this is saying is that the data set has 2 zeros for those 2 dots. It has 4 ones, 2, 3, 4. It has 2 2s, 3 3s, 2 4s, 1 5, and 1 6. So for this one, I'm going to show you how you find the median by hand. For this next one, I'm going to show you how you do it on the calculator. So if you need to do it by hand, what you do is you just start on the left side, cross out a number. Go to the right side, cross out a number. And you just keep going, left, right, until you just have one number in the middle. So we just keep doing this. And we did left, right, and there's only one number left, and it's 2. So that means that this set also has a median of 2. So that also means we can eliminate choice 3, because that says that only 2 and 3 have a median of 2, but we just showed that the first one does too. So at this point, it really just comes down to the third set. If this one does not have a median of 2, then it's going to be choice 1. But if it does have a median of 2, it's going to be choice 4. So let's take a look how we can calculate the median. We're going to do the same thing reading the histogram and just marking how many of each number there are. So there is 1 0. There are 3 1s. 1, 2, 3. There's 5 2s. 1, 2, 3, 4, 5. There are 3 3s again. There are 4 4s. 3 5s. And 2 6s. Oh, I knocked over my microphone. There we go. Alright, let's put those 2 6s. So this is a much larger data set than the other one. And you absolutely can find the median the same way as you did before, but let's do a demonstration of how we do this on the calculator. So let me pull this up a little bit. Oh, that light is not helpful. There we go. Okay, so in order to put in a data set, we're going to go home. We're going to hit 1 for new document, and you're going to add lists and spreadsheet. We're going to label our data set. It doesn't really matter what we call it. I'm just going to call it data. I don't know why it's typing in all caps, but I don't really care. Oh, okay. And then we just type all our numbers in. So we've got 0, enter, 1, 1, 1, and I'm just going to type all of these in. 3. Okay, so once we've got all our numbers in, we're going to go all the way to the top. Oops. And then we're going to hit menu, hit 4 for statistics, 1 for stat calculations, 1 for one variable statistics, and then we just hit enter and enter. We scroll down and we find our median, which looks like it's 3. So the median for that third set is not 2, it's 3. So that means the answer can't be choice 4, because that says that all 3 have a median of 2. So it's got to be choice 1. Now I know, as you know, just like when we did that one in class, that's a long question. It's a lot of steps for just one multiple choice, but again, you have 3 hours. Some of you have more. Take advantage of that time. All right. Let's move on to question 11. There we go. What would be the order of these quadratic functions when they are arranged from the narrowest graph to the widest graph? Oh, this is a good question. So we've got f of x equals negative 5x squared. We've got g of x equals 0.5x squared. And we have h of x equals 3x squared. So we've got these 3 functions, and we're just trying to figure out which one is the narrowest and which one is the widest. So there's a couple ways that you can do that. The first one is just kind of by knowing how the number in front of x squared affects the graph. And basically how that works is if I have the graph of a parabola, which is what all of these are going to be. Let's say this is f of x equals x squared. If I drew another graph, and let's say I wanted to make that g of x equals, let's say, 2x squared, as that number in front of x squared gets larger, whether it's positive or negative actually, it makes the graph wider. Or no. It makes it narrower. Let me rephrase that. So this one's going to be like skinnier basically. It's not going to open up as fast. It's going to shoot up faster. So based on that, we can order these. Basically, whichever number is larger, basically has a larger absolute value, is going to be the narrowest one, which in this case is going to be f of x. F of x is going to be the narrowest one because that -5 is the, quote-unquote largest number amongst all of these. And you might be thinking, well, isn't 0.5 and 3, those are positive numbers, so they're larger, but it has what's called a larger absolute value. So that one is going to be the narrowest. So we need to just pick an option that has f of x as the first one, which narrows us down to choice 1 and 4. So it can't be 2, can't be 3. And now we check the other ones. It's either 0.5x squared or 3x squared, which is the next narrowest. And as I said, the bigger that number is, the narrower it's going to be. And 3 is definitely larger than 0.5, even in absolute value. So h of x is going to have to come next in the order, which means choice 4 has to be the answer because choice 1 has g of x next. So it's got to be choice 4. Now, let's say you get to that question and you kind of forget. You forget about that rule. Well, that's where the calculator comes in handy. Oh, that light's annoying. So, let's just graph them all. Let's hit B for graph. And I already have something graphed in here. That's not what I wanted, so I'm going to make a new document. And I'm going to make a new graph. Come on, focus. So we're going to add graphs. And here, we're just going to put in our functions. So the first one, -5x squared. So there we go. -5x squared. Then we just hit the down arrow so that we can type in another one. And it already graphed it for us. So the next one is 0.5x squared. X squared. We go down one more time. And then h of x is 3x squared. Now you notice this doesn't say f and g and h, just says f1, f2, and f3. That's fine, as long as you can keep track of which is which. So it's 3x squared. Let's just hit enter. And as we can see here, the one that's negative, it's a little bit hard to tell based on this graph, but it is definitely narrower than the 3x squared one, so that one has to be first. And then this one is just a little bit wider, so that third one, and as it's written, h of x comes in second place. And then f2 of x, or our g of x on the problem, is the widest. So we can visualize that difference, which again leaves us with choice 4. All right. We've got a statistics problem. Yay! At Berkeley Central High School, a survey was conducted to see if students preferred cheeseburgers, pizza, or hot dogs for lunch. The results of this survey are shown in the table below. So, here's how we could read this. There were 32 females who preferred cheeseburgers, 44 who preferred pizza, and 24 who preferred hot dogs. And then amongst the males, 36 preferred cheeseburgers, 30 preferred pizza, and 34 preferred hot dogs. So the question is asking us, based on this survey, what % of the students preferred pizza? Now this question is tricky because you might just be tempted to take, 44 or 30 and divide it by some other number here. But in order for us to calculate that, we need to do some division. We need to figure out, the number of students, who prefer pizza, like in total. And we have to divide that by the number of students total. And unfortunately, neither of those numbers are actually given to us here. We have to calculate them ourselves. So, speaking of calculate, let's do that. I'm going to go back home. I'm going to go to my calculate section. So, let's first figure out how many students prefer pizza. So, according to this, there are 44 female students who prefer pizza, and there are 30 male students. So, we add those two numbers together. 44 plus 30 gives us 74. So, that means that we're going to put 74 on the top of that fraction. And then the total number of students. Well, just add all the numbers together. 32 plus 44 plus 24, that's the girls, and then plus 36 plus 30 plus 34. Gives us 200 total students. So, let me put that in here, 200. And now, since we want that as a decimal, we'll do 74 divided by 200, and we're going to hit Control Enter to give us a decimal. It gives us 0.37. Okay. 0.37. But remember, a percent is basically some number divided by 100. So we just need 0.37 times 100 for the percent. And the easy trick for that, move the decimal 2 places to the right. That gives us 37%, which in this problem is choice number 2. And there's our answer. All right. So we got that question done. Let's keep going. We're turning the page again. All right. Which situation could be modeled by a linear function? Oh, this is what we went over. So, again, the main difference between linear and exponential models. No, that's supposed to be a no. Is that linear has a constant rate of change, while exponential growth does not. I'm just going to write not constant. So we just need to check which of these options is changing at a constant rate. Basically, which one is the same amount of something happening every time. So let's look at choice 1. The value of a car depreciates by 7% annually. Well, first of all, that weird word depreciates. Again, that means it goes down in value. But we've got a percent. But that percent is going to change every year. And as we discussed, the second you see percent, you should recognize, yep, that's exponential. So it's definitely not choice number 1. How about choice number 2? A gym charges a $50 initial fee and then $30 monthly. Well, every month it's a $30 charge. It's not a percentage of something. It's not changing every time. The monthly charge isn't changing at all. So it's just $30. So that seems like a pretty strong contender, but, just to be safe, let's check the other options. The number of bacteria in a lab doubles weekly. Well, if it doubles, that means it's multiplying by 2. So that means it's not going to be changing by the same amount every time. Once you see a word like that, doubles or triples or halves or something like that, that's exponential again. So it's not choice 3. And then choice 4, the amount of money in a bank account increases by 0.1% monthly. Again, percent. So that's exponential. So we were right. It's choice 2. All right, and that is question 13. Let's move on to question 14. So we've got 4 functions here. Which function has the smallest y-intercept value? So, what the heck is a y-intercept? Well, remember when we have a graph, if I just draw some squiggly function here, the y-intercept is where the graph crosses the y-axis, which in this case would be right here. And the main thing to note about the y-intercept is what the x value is. If you're right in the center, well, what's our x value? It's 0. So we're just checking what the output of our function is when x is equal to 0. So let's check that for each of these. So for choice 1, let's check where x is 0. Looks like right here. The output is 1. So the y-intercept is 1. Let's check choice 2. We've got h of x equals the square root of x minus 3. And you might be thinking, wait, we've never talked about y-intercepts with square roots. What's going on here? But again, it's the same idea. We just care about where x equals 0. So we just find h of 0. And we just replace the x with 0. And of course, what's the square root of 0? It's 0. So we're just doing 0 minus 3, which is negative 3. So this one has a y-intercept of negative 3. So we already know, that already beat choice 1. So we already know choice 1 isn't going to be the answer. Let's check this one, choice number 3. This time we actually have a graph, which is kind of nice. So we just need to see, where is it equal to 0? Well, this is where x equals 0 right here. What's the y value? Well, from the center, it's 1, 2 down, which gives us a y-intercept of negative 2. Well, we're looking for the smallest y-intercept, remember that. And negative 3 is smaller than negative 2, so it's definitely not that. So now we just have f of x equals x squared plus 2x minus 1. So let's do the same thing we did with choice 2. Let's just plug 0 into our function. So we've got f of 0 equals 0 squared plus 2 times 0 minus 1. Well, what's 0 times 0? 0. What's 2 times 0? 0. And minus 1. And remember, when we have zeros like this, you don't actually have to write them. So 0 plus 0 minus 1 is just negative 1. Which again, is not smaller than negative 3. So that eliminates choice 4 and leaves us with choice 2 as the correct answer. Because negative 3 was the smallest of these y-intercepts. Okay, question 14 done. Let's move on to question 15. When solving x squared minus 10x minus 13 equals 0 by, hey, would you look at that, completing the square, which equation is a step in the process? So I told you guys, completing the square, it shows up on Regents exams. So luckily we did this in class today, so hopefully this shouldn't look too unfamiliar. So remember, when we're completing the square, we always start with b. So b is equal to, in this case, negative 10. Next, we do b over 2, which negative 10 divided by 2 is negative 5. And finally, b over 2 squared. Negative 5 times negative 5 gives us a positive 25. So now, we start to rewrite the equation. Let me zoom out a little bit here. So we end up with x squared. Nope, I already made a mistake. X squared minus 10x. This is where we add our b over 2 squared, so plus 25. And since we can't just randomly add things, we have to subtract 25 as well. And then minus 13. And all of that equals 0. Now, we still don't have any of these options, so we're still getting there. This is the part where we take these first three terms and we do why we're doing this in the first place. We put it in parentheses, we get x, and then we look at our b over 2. And since b over 2 is negative 5, do x minus 5. We square that, and then whatever's left over out here, we just combine. So negative 25 minus 13 gives us negative 38 equals 0. Now, based on the x minus 5 squared alone, we can eliminate two answer choices here. We can eliminate 3 and 4. So it just comes down to choice 1 and 2. So choice 1 has 38 on the right side. Choice 2 has 12. Well, if we were trying to solve this, remember, we would use our inverse operations, and luckily this question doesn't need us to solve the whole thing, but we could start. We add 38 to both sides. So we get x minus 5 squared is equal to 38. That's choice 1. So that's going to be our answer here. And that's how we apply completing the square here. All right. This next one's good. Keep needing to adjust this. All right. When 3x squared plus 7x minus 6 plus 2x to the power of 3 is written in standard form, the leading coefficient is one of these. Well, the main thing to remember about standard form is that the exponents are in descending order. Basically, you start with the largest one and you go down. So the largest power of x we have here is x to the power of 3. So the first term should actually be 2x to the power of 3. Now, we could rewrite the rest of it in the proper order, but all we care about is the leading coefficient, which again is the first one, the one that's in front of the largest power of x, which we can already see is 2. Again, coefficient, that's the number in front, not the power, so don't pick 3 here. It's that 2. So choice 2 is our answer. That's it. That's all we needed to do there. All right. Let's keep moving along. We're getting close here. We're getting close to the end of the multiple choice section. All right. Which of the equations below have the same solution? Ooh, this is a good one. So, we've got 3 different equations here. 10 times x minus 5 equals negative 15. 4 plus 2 times x minus 2 equals 9. And 1 over 3x equals 3 over 2. So, let's try to figure this out. So, first of all, how do you find the solution to an equation? Well, this is something we've been doing for a while. I'm going to rewrite this first equation here so I have some space to work with it. This is where we draw our line through the equal sign and try to figure out what x is. So, first thing we're going to do here, we've got multiplication on the outside of parentheses, so we distribute. 10 times x is 10x. 10 times negative 5 is negative 50. And that's still equal to negative 15. So let's add 50 to the both sides. To the both sides. to both sides, because that's our inverse operations. Plus 50. So we end up with 10x is equal to negative 15 plus 50 is 35. We divide both sides by 10. And we get x is equal to 35 divided by 10. If we throw that in the calculator, that will give us two things. It'll give us a fraction, but it will also give us a decimal if we ask for it. 35 divided by 10, 7/2, or if you just hit Control and Enter, 3.5. So we're going to use both of those. Turn the light back on. So it's 7/2 or 3.5. They're both the same number. So what we can do here, no, not 7.5, whoops, 3.5 or 7/2. We actually don't need to solve all of these, because we can just check if this is a solution to all of them, and we're going to see how we can do some process of elimination based on that. So in order to check that as a solution, all we need to do is just type in the whole equation but replace x with that value. So let's try the second one. Let's do 4 plus 2, and then in parentheses, instead of x, I'm going to write 3.5 minus 2 parentheses, and we hit the equal button up here to write it as a statement, and that equals 9. We're going to hit enter. False. So let's think about what that tells us. We still don't know what the actual solution to choice 2 is, to that second equation, but we know that 1 and 2 do not have the same solution. So let's look at our answer choices here. 1 and 2 only? Well, definitely not, because as we just saw, they don't have the same solution. So it's not going to be choice 1. And choice 4 says that 1, 2, and 3 all have the same solution. So obviously it can't be that, because 1 and 2 don't. So it can't be that. So this comes down to either choice 3 or choice 2. 1 and 3 only, or 2 and 3 only. And in my opinion, the smartest thing to do here would be to just figure out the solution for 3. Because if it turns out to be 3.5 or 7/2, then choice 2 is the answer. But if it doesn't, if it's literally anything else, it's got to be choice 3. That's the only option left. So let's solve this. I'm going to do it over here. No, I'm going to do it over here. So we've got 1/3x is equal to 3/2. Now we've got a lot of fractions here. Not really, there's 2 of them, that's not a lot. So we've got 2 options. We could either just divide both sides by 1/3, like we normally would, or, a neat trick, we could actually multiply both sides by 3. For the sake of simplicity, I am going to divide both sides by 1/3, just to, prove a point that we can do that. And I don't know about you, but dividing by fractions can be a little confusing sometimes. So let's use our calculator. Again, you hit Control and the division sign to do a fraction. So we have 3/2 divided by another fraction, 1/3. We hit enter. Get 9/2. So we now have enough information to make our choice. As we can see, equations 3 and 1 do not have the same solution. So choice 2, which says that 1 and 3 are the only ones that have the same solution, that can't be true. So it's not that one, so we're only left with one choice. And we didn't even figure out the solution to choice 2, but, you know, based on what we did here, it seems there's a pretty good chance that it's 9/2. So that's our answer. All right, I'm going to take a quick little water break. All right, let's get there. Number 18. In an organism, the number of cells, C of D, after D days can be represented by the function C of D equals 120 times 2 to the power of 3D. This function can also be expressed as one of these options. Now, this is a tricky question because there's a couple layers to this. But what it's going to come down to is actually our rules of exponents. So let's think about what we have here. 120 times 2 to the power of 3D. Now here's something you could do right off the bat. When you have a number multiplied by, some base with a power, if there's a variable in that power, nothing about this coefficient is going to change. That 120 is going to remain 120. So, with that known, we can eliminate two answer choices here right off the bat. We can eliminate choices 1 and 2. Because again, nothing's going to happen to that 120. That's going to remain the same. What we care about is 2 to the power of 3D going to turn into 6 to the power of D or 8 to the power of D? And there's a couple ways we can think about that. The first thing we can think about is just by recognizing, well, doing an exponent is not the same thing as multiplication. So 2 to the power of 3, we're pretty sure that's not 6. But we can confirm even further. 2 to the power of 3D. If we remember our exponent rules, particularly the power rule, we know that this is the same thing as 2 to the power of 3, in parentheses, to the power of D. Because whenever you do a power to a power like that, you end up multiplying. So all I really did here was just do that in reverse. Instead of turning 2 to the 3 to the D into 2 to the 3D, I kind of separated it. And that will allow us to do this. Well, what is 2 to the power of 3? Well, we could either remember how to just do exponents or plug it in the calculator. 2 to the power of 3 is 8. So we have 8D, or 8 to the power of D, which means it's choice 4. That's it. All right. Question 19. In the process of solving the equation 10x squared minus 12x minus 16x equals 6, George wrote 2 times 5x squared minus 14x equals 2 times 3, followed by 5x squared minus 14x equals 3. Which property justifies George's process? Well, let's think about what's going on here. What changed from here to here? Well, it looks like negative 12 minus 16. Well, negative 12 minus minus 16x is going to be negative 28x. So where did the negative 28x go? Also, where did the 10 go? And where did this 2 come from? Well, a couple things happened here. Now, I'm actually thinking hard about this question. This is what I mean by the Regents trying to trip you up. Now, it looks like more than one step occurred between this original one here and this step. more than one thing definitely changed here. But what we're seeing here is we went from this step to this step. This is why you read the questions carefully. Even me, your math teacher, kind of misread this question initially. So we care about this step to this step. Basically, what happened from here to here. So if we look at the differences between these two equations, there's really only one difference. Both sides of the equation are multiplied by 2 on the left, but on the right side, those 2's aren't there. So it has to do with something changing between the sides of the equal sign. It has to do with being able to change things on both sides of the equal sign. So if it has to do with, the equal sign and changing equations, then it's definitely going to be one of our properties of equality. And even if you don't explicitly know, I don't know what the addition property of equality is, you don't really have to, because you know it has something to do with the equals, because it changed on both sides. So it can't be choices C or D, because neither of those have anything to do with equality. So we just need to decide, is it the addition property of equality or the division property of equality? And I'm now realizing again that I should have read the answer choices more carefully. But, that's how it goes. So probably shouldn't have crossed all these out. So we're going to ignore that. So we know that one of these properties is going to be it. It has to be A or B, or maybe both. But what it looks like is nothing got added or subtracted from both sides of the equation. What it looks like happened is that 2 that was being multiplied got canceled out. And what's the opposite of multiplication? That's what it's called. The opposite of multiplication is division. So the division property of equality is a good choice here. So if B is definitely one of our choices here, well, which one? Well, it can't be 1 because that doesn't have B. And it can't be 3 because that also doesn't have B. So number 2 and number 4, it's either A and B or D and B. So it's either the addition property of equality or the distributive property. Now, as we said, if we look at what's going on here, it doesn't look like at any stage anything was added or subtracted from one side of the equation to the other. This negative 12x minus 16x, those combined, and then we did some, mumbo jumbo here. Nice going, George. Did some stuff over here, but nothing was added over here. There's still 6 over here. 2 times 3, and then we just divide it. So it's not A. It can't be A, which means it can't be choice 2, which means we're really only left with one choice. And that makes sense, because while we're used to multiplying with the distributive property, doing 2 times 5x squared minus 14x, well, 2 times 5x squared is 10x squared. 2 times negative 14x is negative 28x. So the distributive property actually is part of this. So choice 4 has to be our only answer here. Now, I'm actually going to mark that question with a star, because that is a tricky question. And they know that it's a tricky question. And unfortunately, you're going to get questions like that where it's going to try to throw you off. This is why you take your time. I'm more than an hour into taking this test, and I haven't even gotten through 20 multiple choice questions. It is okay to take your time. Use the time that you have. It's there for a reason. All right. Question 20. We've got a sequence here. A sequence is defined recursively by a1 equals negative 2 and an equals 3 times an minus 1 plus 1. We want to know the value of a4. So we haven't really talked about sequences in a long time, especially recursive sequences. So this might seem kind of scary. But let's break down what this is talking about. Remember that a sequence is just, a sequence of numbers. And they tell us what the first one is. They say that A1 is -2. So we know that much already. And all we want to know is what's A4. So we need to figure out what goes here, what goes here, and what goes here. And they give us a formula. They say that AN is equal to 3AN minus 1 plus 1. Now let's translate that kind of. All this is saying is that to find any given term, it's just equal to 3 times the last one plus 1. So if I want to find A2, for example, I would do 3 times A, well, if n is 2, what's n minus 1? 2 minus 1? 1. Plus 1. And what is A1? Well, it's -2. They told us that. So 3 times -2 plus 1. That's equal to 3 times -2 is -6 plus 1. That would be -5. So we could repeat that process and just, find A3 the same way and then find A4 the same way. Or we could just recognize what the difference is here. -2 times that. But here's the problem. We can't necessarily do that, unfortunately. So we're going to do it the long way. A3 equals 3 times A2 plus 1. Well, what is A2? We just figured that out. It's -5. So we have 3 times -5 plus 1. 3 times -5 is -15 plus 1 is -14. And now we have to do it one more time to find A4. So that's going to be 3 times A3 this time plus 1. A4 equal to 3 times -14 plus 1. 3 times -14 is -42. Well, if I'm uncertain, let's check it. -3. Oh, no. 3 times -14. I think it's -42. Yeah. -42 plus 1, which is -41. And if we look at our answer choices, choice 1. All right. Let's keep going. Also, I don't think anybody's currently watching, so this will be here for you. A swimmer set a world record in the women's 1500 meter freestyle, finishing the race in 15.42 minutes. If 1 meter is approximately 3.218 feet, which set of calculations could be used to convert her speed to miles per hour? All right. This one is weird because this looks like a bunch of crazy math going on, like so much that you need to do. But it's actually not as complicated as you might think. So all we know is that we want our final unit to be miles over hours, or miles per hour. So in order to figure that out, we actually just have to cancel out units. Because remember, if I divide something by itself, it cancels out to just 1. So the same works for units. So let's take a look at the units we have here and see if anything cancels out. So for choice 1, we have meters on top. Are there any meters on the bottom? No. So there's nothing we could do there. We have minutes. Are there any minutes on the bottom? There are. So since there's minutes on the top and the bottom, that means we can cancel them out. Okay, meter. Again, there's no meters on the bottom. There are meters on top. but that's not really what we want. And then mile, well, no, there's no mile on bottom either. So here, we definitely don't end up with miles over hours, because there's too many other units going on here. So that can't be it. Let's try number 2. We've got meters on top. Are there any meters on the bottom? Yes, there are, which means they cancel out. How about minutes? Well, do we have any minutes on the bottom? We do, which means the minutes cancel out. How about feet? Are there any feet on the bottom? Yes, there are. This is looking good. Are there any miles on the bottom? No, there are not. So the units that we're left with on top are miles and hours, which is exactly what we were looking for, miles per hour. Oops. So it's got to be choice 2. And, you know, you could check the rest of these as well, but they will not work out. We can see the meters will cancel out here, the meters will cancel out here, the feet will cancel out here, the feet will cancel out here. This one gives us miles per minute. That is definitely not what we're looking for. And then this one, we've got meters on top, but no meters on bottom, which means the meters don't even cancel out, so it definitely can't give us this. So choice 2 is definitely our answer. All right, let's keep moving. 22. The diagram below shows the graph of h of t, which models the height in feet of a rocket t seconds after it was shot into the air. Oh, excuse me. So, the domain of h of t is one of these. So this comes back to our functions and how we talk about them. So when we see that word domain, the first thing that should come to mind is an input, or again, x. We care about our x values. Now, you might notice we don't have any x values here. However, we do have an input to our function. And as we can see, if the graph is h of t, and you put t seconds into it, even the way it's graphed, the x-axis says t, and the y-axis says h of t. So if our x-axis is representing t here, then that must mean that t is our input. So we just care about what values of t are inputs into this function. Well, it looks like we go from 0 to 4. So just based on that alone, going from 0 to 4 as our input means we can eliminate 2 answer choices. We can eliminate choices 3 and 4. So we need to pick between 1 and 2. And they might look pretty similar, but we need to remember what the difference between those brackets are. The difference between the parentheses and the brackets. So let's kind of translate these into a different kind of interval notation. So the parentheses, 0, 4, that means that x is between 0 and 4, but not including 0 and 4. It'd be an interval like this. So that means that x is anywhere between them, but not actually equal to them. However, when you use the brackets like this, that translates to this interval, which is basically the same thing, except this time, since we've got the less than or equal to signs, we're including 0 and 4. And if we look at our graph here, we have nice normal filled in points at x equals 0 and x equals 4. So that must mean that we're including those values. So therefore, it's got to be choice 2. And that is question 22. All right. Let's keep going. We are so close to being done with multiple choice. Then we get to do the short answer. All right. This is a good one. I feel like I say that about a lot of them. probably tired of hearing me say that, but oh well. The table below shows the time in hours spent by students on electronic devices and their math test scores. The data collected model a linear regression. So we've got this big data set here. What is the correlation coefficient to the nearest hundredth for these data? Now, again, we did not spend a lot of time on this, but I'm going to show you how to do it anyway. So we're going to put in a data set, just like old times. So I'm actually going to turn that off. I want to make sure we can see what's happening here. So I'm going to go to my home screen and I'm going to create a new document. Whoa. That's not going to focus, is it? Oh well. Alright, so do we want to save unsaved document? No, we do not. So we are going to add, let me refocus this, lists and spreadsheet, because we're making a list. So this time, as you can see, we have two sets of data pretty much. I mean, come on. Just trying to focus. There we go. So we have the time spent in hours and we have the math scores. So in the list in our calculator, I think we should label them accordingly. So, fine. So let's call the first one hours. Again, you can call it technically whatever you want, although it would probably be in our best interest to just call it X and Y. Whenever you're doing linear regression, X and Y makes your life easier. So we've got our X list and we've got our Y list. Now we just put in our data. So we've got 3, 1, 4, 0, 3, 7, 5, 2. So that's our first list. And then we put in our Y list. 85, 99, 81, 98, 90, 65, 78, and 90. So they line up nice. That's what we want. So you want to have the top right number in your list selected when you do linear regression, when you do this calculation. I think we only spent one day on this in class, so it pays to, watch this and see how this process is done. We're going to hit menu. You're going to go to statistics 4, just like we do normally. You're going to hit stat calculations again, but this is where it changes. Instead of hitting 1, you're going to hit 3 for linear regression. Now, once you're on this menu, you actually do need to change something. You need to change the X list and the Y list. The X list, put X, or whatever you put in for your X list. If you ended up putting in hours and then the other one, score or math, just make sure you type in the exact same thing. So we've got X, we've got Y, and then if you scroll down, the first result column should say C. You shouldn't have to change anything there as long as you put it in the right place. It should say C with those little brackets. Then just hit enter. And it's going to give you a bunch of numbers here and a bunch of random looking stuff. But all we care about right now is the correlation coefficient, which is represented by R. That doesn't look like an R. That's a little better. So we just need to find R on this list. And of course, right there we have R squared, but that's not what we want. We want R. So if we look at that value, it's negative 0.97718, a bunch of other stuff. What we want is that number to the nearest hundredth, so the second place. So if we look at that number, the hundredth place, it's that 7. The next number there is a 7, so we have to round up. So that's going to become negative 0.98. So r equals negative 0.98. And would you look at that? Choice 1. It's there. Love when that works out. So choice 1 is going to be our answer. So there's really not much math that was done there. That was really all just knowing how to put it in the calculator and calculate the value. So knowing how to do that is important. If you at any point need me to show you again how to do that, I'd be more than happy to do so. But for the time being, let's finish up these multiple choice questions. The volume of a trapezoidal prism can be found using the formula V equals 1/2 A times B plus C H. Which equation is correctly solved for B? So we need to solve this equation for B. Now that's a process, but we're algebra students. We know how to solve equations. So let's just rewrite it off to the side here. V equals 1/2 A times B plus C H. So again, we want to get B by itself. So let's think about how we can do that. Let's drop our line because we're going to be solving. Now, believe it or not, there's not as many steps here as you might think. And I'm going to show you what I mean by that. All these things that are just kind of next to each other, the 1/2, the A, the B plus C in parentheses, and the H, they're all being multiplied by each other. That's what that means. So when we have a bunch of things multiplied by each other, how do we cancel that out? The opposite of multiplication, division. So why don't we just divide everything out that isn't the B plus C, because we can't really do anything with that C yet because it's in the parentheses. So let's just divide this by 1/2 A H. So let's see what that gives us. We divide over here by 1/2 AH. So that leaves us, let me actually draw that a little lower, V over 1/2 AH equals B plus C. And now we actually only have one more step. We just need to subtract C from both sides. So minus C. And what we get for B is V over 1/2 AH minus C. Now, here's the problem. You might notice that that's not any of the answer choices. But don't panic, because we do have the right answer here. It's just written a little differently. The first thing to notice is that 2 of these answer choices have plus C, and 2 of these answers have minus C. Well, we got a minus C here. We subtracted C from both sides, so it definitely can't be choices 1 or 3. So which one is it? Is it V over 2AH or 2V over AH? And we find our answer by thinking about what it means to divide by a fraction. Now, when you divide by a fraction, you're kind of dividing by something that's already been divided. And kind of like with negatives, it actually cancels out a bit. So this V over 1/2 AH, dividing by 1/2 is actually the same thing as multiplying by 2. So this could be rewritten as 2V over AH minus C equals B. And when you do that, then you can see, oh hey, choice 4, that's exactly what we got here. It's just knowing that you have to do this. Now we could have avoided the fraction altogether if over here, instead of dividing by 1/2, we just multiplied by 2. But we could still get from what we did to the correct answer, which is 4. Okay, well, that concludes the multiple choice section of the test. We are about an hour and 40 minutes in. Look at that. So again, I'm taking my time here. Might need to pick up the pace a little bit, but that's fine. So we are going to move on to the short response section now. I see that someone's watching, so if you're there, hello, good to have you here. We're going to move on to the short response section, and again, if you have any questions, just ask them right in the chat. Now, big thing to remember. It's going to say it somewhere in here. For all questions in this part, a correct numerical answer with no work shown will receive only 1 credit. Basically what that means is if you write the answer, even if the answer is correct, if you don't show any work, you will not get any credit. So please keep that in mind. Show as much work as you possibly can. So first thing we're going to do here is we're going to graph a function. F of x equals the absolute value of x plus 1. Now, big thing to remember, what do these two lines do? Well, if I take the absolute value of something like -3, let's say, it turns it into 3. But if I took the absolute value of 7, it would just be 7. It takes negative numbers and turns them positive. And for positive numbers, it doesn't do anything. So we have a couple approaches here. Unfortunately, the graph paper did not print very well here, so I'm actually going to draw in some of my own lines here. I promise the Regents will look better than my printout here. I don't need a ton of lines here. I'm just going to get enough to prove a point. Again, I promise you will not have to do this. Good enough. So we could just put this in our calculator and copy some values down. I'm so serious. Let's do it. Because there's nothing wrong with doing something the easy way. Because if you know how to do it, then do it. We're going to make a new graph. We're going to hit 2. And our function here, f of x equals the absolute value of x plus 1. For that absolute value symbol, you hit Control, and you hit the equal button here, and a menu will come up. You want that line there. So we've got the line. It's x plus 1. We hit Control equals again. Get the other line. Hit Enter. Never mind, that must not be the right line. Well, it was bound to happen at some point. So let's do some troubleshooting here. Let's see if we can figure out how to do absolute value on here. Maybe we can't. Well, you learn something every day. Okay, that's fine. We'll make our own table. X and f of x. Let's get a couple values here. So, one feature of these, whenever you have a function where you're adding 1 on the inside like that, that just takes whatever the function would have been without that and shifts it to the left by 1 in this case. So this isn't going to be, centered very far from the middle of the graph. So let's start with something like -3. We'll do -2, -1, 0, 1, 2, 3. That should get us enough information to properly graph this. So what happens when we plug -3 into our function? Well, f of -3, if we replace x with -3, that would be the absolute value of -3 plus 1, which would be the absolute value of, well, negative 3 plus 1 is negative 2, which gives us 2, because that's how absolute value works. So that's the first point. So in order to get that, negative 3 comma 2, we go 1, 2. I'm going to draw another line so it's visible. These are awful lines. 1, 2, 3, and then up by 2. Okay, got our first point. Let's plug negative 2 into the function. F of negative 2 is going to be the absolute value of negative 2 plus 1, which is the absolute value of negative 1, because negative 2 plus 1 is negative 1. That's 1. There's another point. Negative 2 comma 1, so 1, 2, up 1. There's our next point. And I know it's a little bit tedious, but just plug them in. F of negative 1, absolute value of negative 1 plus 1. Negative 1 plus 1 is 0, and the absolute value of 0 is 0. All right. Got another point here. Again, your graph will be much more even than mine. Let's just plug in the rest of these. We plug in 0. I'm going to kind of speed along here. You'll notice a pattern as we plug these in. We replace x with 0. 0 plus 1 is 1. And the absolute value of 1 is 1. So 1. If we plug 1 into this function, 1 plus 1 is 2. The absolute value of 2 is 2. Plug 2 in. 2 plus 1 is 3. Absolute value of 3 is 3. And finally 3. 3 plus 1 is 4. Absolute value of 4 is 4. So 0 comma 1 goes right here. 1 comma 2. 2 comma 3. And 3 comma 4. And of course, whenever we draw a graph, what do we like to do with it? We like to connect the dots the best we can. You will be provided with a ruler on the Regents. Please use it. Now, this graph, technically, I could have written in pencil. And honestly, maybe I should have written in pencil, because if you mess up a graph, that's kind of annoying. But in the event that you do draw a graph in pen, which I don't recommend, if you make a mistake, redraw the graph in the way it's supposed to be and make sure you mark in some way that you made a mistake, that you don't want them to count that graph. Because you can do that. If you mess up, it's not the end of the world. All right. First multiple choice question, no. First short response question, done. Let's keep moving. 25 questions down, 12 to go. We're way more than halfway done. Okay. The table below shows the value of a particular car over time. So let's look at what we've got here. Here's the time in years. It goes in intervals of 5. We go from 20,000 down to 10,550, 5,570, 2,940, 1,550. So we want to figure out whether a linear or exponential function is more appropriate for modeling this data. So this is very close to what we talked about last week. We tried to figure out, how do you tell the difference between a linear function, a linear model, and an exponential model? Well, one thing that is key about a linear model is, we said this earlier on this test already, is it has a constant rate of change. That is the main thing you should look for when you're looking for linear. Basically, as our time increases, is the value changing by the same amount every time? And we can check that. First of all, let's just check that our intervals are even. 0 to 5, that's 5 years. 5 to 10, that's also 5. 10 to 15, that's 5. 15 to 20, that's also 5. So these are going up evenly. But we need to check, are these? Is the difference between 20,000 and 10,550 the same as the difference between 10,550 and 5,570? Well, you might already have an answer in your head, I know I do, but again, they like you to show work. They like you to explain your choices. So let's actually find out. 20,000 minus 10,550. Let's see what the actual change was. I'm going to put that right in the calculator. Not here. So 20,000 minus 10,550. It's 9,450. Okay, and then let's try 10,550 minus 5,570. Let's see what that gives us. Do the same thing, just plug it in the calculator. We get 4,980. So, as you can see, these two numbers are pretty different. It's not changing by the same amount every time. So, is it going to be linear? Well, no, it can't be. It doesn't have a constant rate of change. So, our answer here would be exponential. And here's the word you're going to hate. Because, and we can really just say something as simple as the rate of change is not constant. That's it. You could circle that. You don't necessarily have to, but it doesn't hurt. And again, we've explained ourselves. We've even writing this up here, that linear is a constant rate of change, showing that that rate of change is not the same every time, and then claiming it's exponential because the rate of change is not constant. Done. That's it. That's really all you need to do here. All right, and that's question 26. Let's move on to question 27. I can't wait. Okay. Is the product of the square root of 8 and the square root of 98 rational or irrational? We need to justify our answer. So, there's a quick check we can do here. Because let's establish something about rational numbers and irrational numbers. So a rational number is any number that could be represented as a fraction of integers. So I'm just going to write a fraction of integers. And remember, an integer is just a number without a decimal or a fraction. But an irrational number is a number that has a non-repeating, and these are the words you really want to remember, non-repeating, non-terminating decimal. So basically, if the decimal never ends, if it goes on forever, but it doesn't repeat, it's basically just a random string of numbers the whole time, that's an irrational number. And one key thing is if you take the square root of something that's not a perfect square, it's not going to be rational. It's always going to be irrational. So one check we can do here to see if, the product of these two numbers is rational or irrational is just find out what the product actually is. And remember, the word product means multiplication. It means you're multiplying the two numbers together. So let's try it. Before we do anything, before we, overwork ourselves, let's do the square root of 8 times the square root of 98. And again, that's something you can just plug in right on the calculator. The square root of 8 times, make sure you go on the outside of the square root, the square root of 98 gives us 28. And based on this definition here, that a rational number is a fraction of integers, an irrational number is, non-repeating, non-terminating decimal, 28 is pretty clearly a rational number here. It ends. If we're considering, decimals here, that's the same thing as 28.0. It's just a whole number. It's an integer. So we can literally say rational because, and there's that because again, I know we hate that, square root of 8 times the square root of 98 equals 28, which is a rational number. Now, you probably could get away with just writing this, but everything that was written up here, it shows that you know why that's a rational number. It shows that you know what a rational number is, what an irrational number is. You see the multiplication happening, and then here's your actual answer and your justification. And that's question 27 done. Let's keep going. All right. The ages of the last 16 United States presidents on their first inauguration day are shown in the table below. So we've got all of these values here, and really doesn't look like they're in any particular order, at least it's a little hard to tell. And our goal is to determine the interquartile range of this set of data. So this is another one of those things where the calculator is going to put in a lot of work for us. So if we want to find out the interquartile range, let's remember what that is. That's our third quartile, Q3, minus Q1. So all we need to do is plug this data into the calculator and figure out what those two values are. So I'm going to go to home, I'm going to make another new document, and I'm going to go to Add, Lists, and Spreadsheets. We'll label our list. We'll call it age, because why not? And let's put our numbers in. So I'm just going to go across each row and then go down. So I've got the top row, 53, 55, 56, 61, 52, 69, 64, 46, 54, 47, and 70. And they were very kind and literally gave you the number 16, and we can indeed see that there are 16 numbers in this set. So we're going to go right back up to the top, and we're going to do our normal stat calculation. We're going to hit Menu, 4 for statistics, 1 for stat calculations, 1 again for one variable statistics, and then enter, enter. So let's figure out what Q3 and Q1 are. So it looks like Q3 is 61.5. And Q1 is 51. So now we just need to subtract those numbers, which you can either do on your own, or you can do it right on the calculator. 61.5 minus 51, 10.5. Done. Now, this is a good example of one where it's pretty easy to show the work. Like, if you just wrote 10.5 and circled that, you would get half credit. You would not get full credit for that. You have to show this is what the interquartile range is. These are the numbers I'm subtracting. This is my result. I know it's annoying, but you gotta do it. And look at this. You got all this space here. I know you guys get mad at me for not giving you enough space on worksheets and stuff, but the Regents gives you plenty of space. All right, question 29 time. It is also worth noting that it looks like I have been live for exactly 2 hours. So at this stage, if you have finished the test already, you can leave. But you do have 3 hours to finish the test, and there is nothing wrong with using all of that time. All right. The cost of 1 pound of grapes, G, is 15 cents more than 1 pound of apples. The cost of 1 pound of bananas is twice as much as 1 pound of grapes. So we want to write an equation that represents the cost of 1 pound of bananas in terms of the cost of 1 pound of apples. So let's think about the information that we know. Don't get too caught up in what the end goal is. Let's see what we know first. So the cost of 1 pound of grapes, G, is 15 cents more than 1 pound of apples. So let's translate that sentence into math. So G, that's the first thing that's really given to us, is, and again, when you see is in a statement, how do you translate that into math? Equal sign. So G equals 15 cents more than 1 pound of apples, A. So let's think about how could we write 15 more than A? Well, A plus 15. So that gives us a representation of the cost of grapes in terms of the cost of apples. Then we want the cost of 1 pound of bananas, B, so let's start with B, is twice as much as 1 pound of grapes. So let's think about what that means, twice as much as something. Well, what do we do when we want twice as much? Well, we multiply by 2. So again, 1 pound of grapes, that's G, so we would just do 2G. But now here's the problem. We want an equation that represents the cost of 1 pound of bananas, okay, we kind of already have that, in terms of the cost of 1 pound of apples. Right now we have it in terms of the cost of grapes. But we want basically some equation where it's G equals, and it's something with an A in it. Well, think about how we could do that. Again, use what you know. We know, oh wait, that should be a B. My bad. So we know that B equals 2G, and we know that G equals A plus 15. So what if we just rewrote it? What if we just wrote that 2, but instead of G, we replaced it with A plus 15, because we already established they're the same thing. So A plus 15. And of course, it would definitely not hurt to simplify this. So when you have something multiplied on the outside of parentheses like that, we can distribute. So we end up with B equals 2 times A is 2A. 2 times 15 is 30. And there's our equation. 2A plus 30. And that's the cost of 1 pound of bananas in terms of basically an equation that has A in it, 1 pound of apples. And we're done. I feel like some of these are going faster than the multiple choice, which is fine as long as you're putting in the work. All right, let's keep moving. A student is given the functions f of x equals x plus 1 squared and g of x equals x plus 3 squared. We want to describe the transformation that maps f of x onto g of x. Now, this is another one of those, questions that uses some slightly fancier language. It's like, oh, transformation, and it maps this onto this. But basically what this question is asking is if you want to go from f of x to g of x, the two functions that they give you right here, what's the difference between them? Like, what happens when you go from f of x equals x plus 1 squared to g of x equals x plus 3 squared? Well, we could use, some math knowledge. We could use what we know about transformations. Or, you already know what I'm going to say, we could just put them in the calculator and see what the difference is between them. So, let's do that. Why not? We like to graph. So, we're going to go home. I'm going to make a new document just so we can, have a fresh slate here. Add graphs. And the first one I'm going to do is f of x. So in parentheses, x plus 1 squared. I'm going to go down, so that's the blue one. And then x plus 3 squared. I'm going to hit enter. So we basically just want to describe what change happened between the blue parabola, the blue graph, and the red one. Well, we kind of can scroll around a little bit here. We can see that they're on the same, y level. They don't move up or down at all. They're on the same level there. But what happened from blue to red? How far did it move? Well, it looks like it was shifted over to the left. And by how much? Well, it was shifted over by 2. Well, if we want to show work, here's something we could do. Draw a sketch of the two graphs. And I know it's tempting to not show any work. It's like you've got the answer right there, so why not just write it? But again, it really does make a difference. So we can kind of just make a really basic sketch here. -1, -2, -3, -4. And just, we can see what the graphs look like. It kind of hits the x-axis at 1. So there's f of x. And then g of x, or f2 of x as it's written on here, hits the x-axis at -3. So we just draw another parabola. And we label that one g of x. And now that we've got that, we can say something along the lines of, I'm trying to think of the right wording to write here. Describe the transformation that map. I mean, you could say something as simple as shifts 2 units to the left. There you go. You've drawn a graph, you've shown like what is actually happening, what the difference between them is, and you're describing it. It shifts 2 units to the left. There you go. That is the transformation that maps f of x onto g of x. It shifts it 2 units to the left. And we're done. That's it. All right, we're moving along here. We're in the 30s. There's 37 questions total. We're almost there. I can feel it. This is the question I've been waiting for. Solve 3x squared minus 5x minus 7 equals 0 algebraically for all values of x, rounding to the nearest tenth. Now, all algebraically means is, don't graph it. Like, don't just graph it and find the zeros that way. You want to use algebra to solve this. Now, we literally, again, we did this in class today. Can you guess what formula we're going to use to solve this problem? You guessed it. The quadratic formula. Which, if we have forgotten, again, it will be provided to you on the exam, so you don't need to worry about memorizing it. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you'd believe me, I am actually wearing my quadratic formula shirt right now, but I couldn't set up my webcam at the same time as the document camera here, so you're just going to have to trust me on that. So, whenever we're using the quadratic formula, we need three things. We need a, b, and c, which we can find by just looking at the equation itself. What's in front of x squared? It's 3, so that's our a. B, -5, and C, -7. So at this stage, we just plug all the values into the formula. So x is equal to negative, and then our b is -5, so we end up with that weird negative thing, plus or minus the square root. Again, b is -5 minus 4, a is 3, extend that a little, c is -7, and that all gets divided by 2a, or in this case, 2 times 3. So let's simplify a little bit. X equals. Now technically we don't actually have to simplify very much because we are just going for the nearest tenth. So if it ends up being a decimal, we'll be able to keep it. But it does not hurt to simplify it a bit more. So x equals, well, what's -5? Negatives cancel out, that's just 5. Plus or minus the square root. And again, if you want to figure out all that stuff under there, just throw it in here. I'm just going to go to calculate, and I'm going to do parentheses -5 squared minus 4 times 3 times -7. I'm going to hit enter, get 109. So all of that stuff under the square root just simplifies to 109. And that gets divided by 2 times 3 is 6. Now, this question is very kind to us because it doesn't want the exact answers. It wants them rounded to the nearest tenth, which means we can just put all this in the calculator and figure out what that gives us. Now remember, this is how we use plus or minus. It gives us two solutions. One of them is the number where it's 5 plus the square root of 109 divided by 6. And the other one is x equals 5 minus the square root of 109 over 6. And we just put both of those in the calculator and round them to the nearest tenth. So let's do that. So the first one, I'm going to make a fraction, control divide. Hit the control button, hit the division sign. 5 plus, hit that button, and then the squared for square root. 109. We get out of the square root and we go down. 6. We get 2.57338. Well, if we're rounding to the nearest tenth, remember that's like the first decimal place here. So we check, are we rounding up or down? It's a 7, so we are rounding up. So that's going to give us 2.6. There's one solution. And now the other one. We just do the same thing, except it's a minus this time, and we could even just copy the answer in, edit it a little bit, turn that into a minus sign. So once again, we round to the nearest tenth. The 10 spot, there's a 9, there's a 0 there, so it's just going to be -0.9. and we've got our two solutions. So as you can see, the Regents does give you plenty of room. We still had even more room to spare, and I wrote pretty big here. So they give you room to do this work, so do it. Like, actually do the steps. It will not hurt you, it will only help you. Alright, so that is our solution to question 31. Let's keep going. Factor completely. So we've got 3y squared minus 12y minus 288. So factoring. We spent some time doing this last week. So we just need to figure out what we can factor out of there. So again, the first thing you should check for when you are factoring is the GCF, the greatest common factor. So let's check. 3y squared minus 12y minus 288. As far as y's go, not all of the terms have a y, so we can't factor that out. I'm just going to rewrite the expression here. But it looks like they do all have a number in common. It looks like we've got a 3. But, because, you know, negative 12 is divisible by 3. But just to be sure, let's do negative 288 divided by 3. And yeah, gives us negative 96. So we can rewrite this. We factor out that 3, and we get, you know, we divide that by 3, we get y squared. Negative 12y divided by 3 is going to be negative 4y. And then 288, or negative 288, as we just saw on the calculator, divided by 3 gives us negative 96. So here we are now. Now we need to factor that. Because as much as it might look like we're done, we are not. Because remember, when you have a quadratic that looks like this, a polynomial that looks like this, you can factor that even more. So remember, 3, and when we're factoring, we have our 2 sets of parentheses. Now the first question, what's going to go at the beginning of our parentheses? Well, normally the answer to that is x, but in this case, x isn't our variable. Our variable is y. So we're actually going to start with y this time. And then we check our signs. Well, is it going to be plus plus, minus minus, or one of each? Well, the first thing we notice is that both of these are negative, especially this one, our constant term. Our constant term is negative. What does that mean? One of each. So at this stage, it's really just about figuring out what numbers go in there. What are some numbers that multiply to 96, or specifically to negative 96, but add to negative 4? Now this is one that's not very obvious, so we need to just get a little bit creative. So let's just divide 96 by some numbers and see what happens. Let's do 96 divided by, I don't know, 3. We got 32, but is there any combination of 3 and 32 with adding and subtracting that's going to get us negative 4? I'm going to go with no. I don't believe there is. So let's try some other numbers. Let's try 96 and 4. Why not? 4 and 24? Well, 24 minus 4 is 20, and 4 minus 24 is negative 20. Still not negative 4. So still not what we're looking for. 96 divided by 5? Definitely not. That's not going to divide evenly. How about divided by 6? 6 and 16. I feel like we might be getting warmer at least. 16 minus 6 is 10. And 6 minus 16 is negative 10. Still not negative 4, but we're getting somewhere. How about 96 divided by 7? Nope, that's just a fraction. 96 divided by 8? 12. Let's see if that works. 12 minus 8 is 4, but 8 minus 12, let's just double check. Oops. Does 8 minus 12 work? -4. It does. So that's our numbers. 8 and -12. And now we have factored it completely. This one doesn't even need us to solve it because, you know, as we did in class today, if you set that equal to 0, we could solve it using that, but we just wanted to factor it. And there's really nothing left for us to do now. So that right there is the completely factored form of that polynomial. And now we're done with it. All right. Question 32 is complete. We're almost there. We only got 33, 4, 5, 6, and 7 left. 5 more questions. Now we are on to the part 3 questions. So the part 3 questions, they all have multiple parts to them. So, you know, they're a little bit more involved. So, let's read the problem. And the same deal, show your work. Thomas took a 140-mile bus trip to visit his grandparents. His trip is outlined on the graph below. So it looks like on our x-axis we've got hours, the time, and on the y-axis we have miles, the distance. So this is just telling us how far he went in any given number of time, or amount of time. So, first part of the question, explain what might have happened in the interval between D and E. So let's just make sure we know what we're talking about here. That's D, that's E. So, what happened there? Well, it looks like time was still increasing, but distance was not. So, what could have happened? Now, let's think practically, like, he's on a bus trip, and then, you know, a couple hours into the trip, he stops for a little while. What could that have been? Well, he could have been changing buses. The bus could have stopped for some reason. But let's use the bus transfer, because that seems like a good option here. We could say Thomas, you know, had to change buses, or had to stop and change buses. 2 S's? No. Thomas had to stop and change buses. Done. State the interval in which the bus traveled the fastest. So let's think about how we could figure that out. Now this comes down to rate of change. So I think a couple intervals that we can eliminate here are B to C and D to E, considering, you know, he was stopped during that time. But when we're thinking about fastest and we're thinking about graphs, the thing that comes to mind is slope, or, you know, rate of change. So we could also just check, like, where is the slope the steepest? Well, between AB and CD, it's not particularly obvious. I would say it's definitely not E and F, because that looks a bit slower than the rest of them. So I'm going to say it's not E and F. So it's either going to be A to B or C to D. And the question is, how do we actually find that rate of change? Well, let's just look at it. I'm going to move the camera in even closer. So it looks like going from point A to point B, how long did that take? Let's see here. Well, these are hours, each one of these lines here. Again, they're not particularly visible on here, but they're there. So it looks like that was half an hour. And how far did he go? Well, looks like he went right up to here, 20 miles in half an hour. Well, let's do 20 over 1/2, which again is the same thing as just multiplying by 2. So that's 40. So let's check the next one. From C to D, well, he started at C at 1 hour, got to point D at, it looks like, let's just follow this down. Looks like 2.5 hours. So here's what we do. We do the distance here, which is 110 it looks like, minus the distance at C, which is 20. And we divide it by the time. So we basically did, where he ended up and where he started. So subtract those, find the difference. And then 2.5, so 2.5, minus 1. We're going to plug that into the calculator, which I've got right here. So 110, I'm trying to show everything here. 110, oops, need a fraction. 110 minus 20, 2.5 minus 1, that gives us 60. So it looks like from C to D, that's the fastest interval for this bus. So, state the interval in which the bus traveled the fastest, C to D. And what's nice about the way that we just approached that problem is that the next question, we actually already answered it. State how many miles per hour the bus was traveling during this interval. 60 miles per hour. And they will care. You can't just write 60. Write 60 miles per hour. And finally, what was the average rate of speed in miles per hour for Thomas's entire bus trip? Well, all we need to do for that is figure out how far he went and how long it took. So it looks like he ended his trip 140 miles in, so we could do 140 divided by how long did it take? Looks like 4 hours. So we do 140 divided by 4. And once again, we plug that in the calculator. 35. So our answer would be 35 miles per hour. Done. So there was kind of 4 questions in one, which can be annoying. I know that. But all of them are connected to each other. It's all the same data. It's all part of the same problem. And we pulled it off. So that's question 33. Let's move on to 34. Oh boy, we get to graph again. I know, that's exciting. And again, the graph paper looks horrible. So we're going to do our best. I'm going to make some lines here. Try to make this somewhat acceptable. And I'll make more if I have to. Alright, so we've got 2 functions here. F of x equals x squared minus 4x plus 3, and g of x equals 1/2 x plus 1. Our goal here is to state one value of x that satisfies f of x equals g of x. So there's 2 things we really need to do here. We need to make a graph of both of those functions, and we need to figure out a value of x that satisfies that equation, f of x equals g of x. So before we touch that, let's just do our graph. And what better tool to use for graphing than our calculator? So let's do that. Let me refocus it. And that made it worse. Come on. Good enough. So we're going to go into our graph again. I'm going to make a new document. No, I'm not going to save the old one. Add graphs. I'm moving closer so we can actually see. Man, I'd love this thing to just work properly. Why is it good enough? So we've got the first one, x squared minus 4x plus 3. So I'm going to type that in. Minus 4x plus 3. Going to go down. So I can do another one. And then a fraction, 1 over 2 x plus 1. And hit enter. So we've got our two graphs here. And if we're going to actually graph them, then we're going to want to look at our table. Now, one nice thing is this one, 1/2 x squared plus 1. That's in slope-intercept form, aka y equals mx plus b. So we could actually just graph that one by hand. That might actually save us some time. So let's start there. For this function here, we need a slope and we need a y-intercept. That's what we always need when we want to graph a line. So our slope is 1 over 2, and our y-intercept is 1. So we start at our y-intercept, and since, remember, slope is rise over run, we go up 1, right 2. And we repeat that process. And I know it's not super visible on here, unfortunately. And then we do the reverse. Oops. Good enough. Ignore that dot. We're going to connect all of them, and when you do this on the Regents, you're going to do it with a ruler because you want your line to be straight. And then whenever you're graphing more than one equation, label them. So this one, you can even just say this is g of x. So we've got g of x, now we need f of x. And we're going to use the calculator for that. We're going to go to our table, we're going to hit menu, we're going to hit 7. 1 for split screen table. And then you could just check the values and plot the ones that you need. So let's start right at the center. Let's start at when x is 0. So this is saying that when x is 0, let me turn the brightness up on here a little bit. When x is 0, y is 3. So we can put a point there. X equals 0, 1, 2, 3. Let's do some more. When x is 1, y is 0. So a point goes there. When x is 2, y is negative 1. Oops. When x is 3, y is 0. When x is 4, y is 3. And honestly, that's probably enough. Now, here's a very important thing. Don't get the points mixed up. Make sure you know this one, this one, this one, this one, and this one are part of f of x. This one is not. Neither is this one. This one, it actually is. It ended up on both of them. I wonder if that's going to be important. So now that we've got these points, let's try to make a graph. Let's connect all these points in our parabola shape, draw our arrows, and label it f of x. So we've got a parabola, and we've got a line. And they're both graphed, they're both labeled, so we're halfway done with this question. But now, the second part. Based on your graph, state one value of x that satisfies f of x equals g of x. Well, all that really means is, where do these two functions intersect? Like, the two graphs, where do they intersect? Well, as I pointed out before, when we graphed them, they share this point right here. And I'm going to circle that point because it's important. And I'm actually going to mark the coordinates of it. It looks like it is 1, 2, 3, 4 to the right. So the x-coordinate is 4. And it is 3 units up. So 4, 3. So for our explanation here, because we did label that point on the graph, that would be showing work. Based on your graph, state one value of x that satisfies f of x equals g of x. We could write x equals 4. Because, remember, whenever you see that word explain, you want to use because the point, and we're going to use that point that we just picked, the point 4, 3 lies on both graphs. Done. We made a graph, and we made a conclusion about those two functions based on the graph of them. And that's it. That's the question. Again, whenever you have a multi-part question, because the part 3 and part 4 questions will be, answer all the parts. Do not just graph and not answer this question, because you will lose half the points. And these types of questions are worth 4 points. So you'll lose 2 whole points here if you don't answer that. So really try to answer all parts of every question, even if you literally have no idea. And I hate saying that, but even if you have no clue how to answer a question, guess, make something up. Do not leave anything blank. All right, on to question 35. We're so close. 3 more. All right, another fruit question, because why not? So, a store sells grapes for $1.99 a pound, or $1.99, strawberries for $2.50 per pound, or $2.50, and pineapples for $2.99 each. Jonathan has $25 to buy fruit. He plans to buy 2 more pounds of strawberries than grapes. He also plans to buy 2 pineapples. If x represents the number of pounds of grapes, write an inequality in one variable that models this scenario. Okay. Well, we've got a lot to do here. We've got a lot of information here that we need to process, a lot of information we need to combine. So let's get to it. Now, again, when you have a bunch of information like this, write what you know. Write things down, try to bring things together. So the grapes are $1.99 a pound, strawberries are $2.50, pineapples are $2.99, and he has $25. That's what we know. He plans to buy 2 more pounds of strawberries than grapes, and also plans to buy 2 pineapples. So let's first just establish some variables. Let's say G equals pounds of grapes, S equals pounds of strawberries, and P equals pineapples. So let's think about what we know about all of these different things. And we could write one big equation with all of these variables and then kind of work our way into one where there's just one, because that's what they want. They want one variable. So there should only be one letter in our final equation here. So let's just start with this. How much are grapes per pound? 1.99 or 1.99. So we could write 1.99G plus, for strawberries, it's 2.50, so 2.50S. And pineapples are 2.99 each, so plus 2.99P. And he has $25 to buy fruit. Now we know we're writing an inequality here. which means we're going to be using either less than, greater than, less than or equal to, greater than or equal to. So let's think about which ones make sense. If he has $25 to buy fruit, he can spend all 25 of that. There's nothing wrong with that. So it's not going to be less than or greater than. Now we just need to think, well, can he spend less than 25 or more than 25? And typically when you go shopping, you can't spend more money than you have. So we're going to say less than or equal to 25. But again, here's the problem. We need one variable. Currently we have 3. So let's see what we know. I think the first most glaring piece of information, he plans to buy 2 pineapples. So we know that P is going to equal 2. That helps. In addition, he plans to buy 2 more pounds of strawberries than grapes. So how do we translate that? Well, that means that the number of strawberries that he's going to buy is 2 more, or the number of pounds of strawberries, rather, is 2 more than the number of pounds of grapes. So that would mean that S is equal to G plus 2. So that means we could replace the S in this equation with G plus 2. So let's try that. Let's rewrite this. So we have 1.99G, that doesn't change, plus 2.50 times, instead of S, we're going to write G plus 2. And then we're going to rewrite this part, but instead of P, we're going to write 2, because he's buying 2 pineapples. And that's still all less than or equal to 25. And now at this stage, we just kind of want to simplify things a bit. So first thing, 2.99 times 2. Let's get that out of the way. 5.98. All right, cool. So that's going to be that. But also, we've got some distributing to do. So let's write another step here. 1.99G plus 2.50 times G is 2.50G. 250 times 2 is 5. And we just determined that this is 5.98. And that's all still less than or equal to 25. And we only have one more simplification step we need to do here, and then we'll have an equation in simplest form with nothing left we really need to do to it. We're going to combine like terms. So 1.99G, let me move down a little bit. 1.99G plus 2.50G, well, just add those two numbers together and slap a G in front of it. So 1.99 plus 2.50 is 4.49. So we end up with 4.49G plus, and then we'll just add these two numbers together. So we've got 5 plus 5.98. We get 1098. And that is still less than or equal to 25. And there's our inequality in one variable. So we took a bunch of information that started with 3 variables and we converted it into just one, just G. And luckily it's in terms of G. That's going to help us here because the next part of the question is asking us to determine algebraically the maximum number of whole pounds of grapes he can buy. So let's do it. Let's take our inequality here and let's solve it. we've already created it. We might as well go all the way. So I'm just going to rewrite it. And we just have to use our inverse operations. Drop our line through the inequality sign. And we start off with addition and subtraction, which in this case, I've got 1098. That cancels out. We get 4.49 g is less than or equal to 25 minus 1098. 1402. All right, last step. We divide by 4.49. And we get g is less than or equal to 14.02 divided by 4.49. 3.12249. Well, we need to think about if that actually makes sense as our answer. Let's read the question again. Determine algebraically the maximum number of whole pounds. So we don't care about how many exact pounds, we care about how many whole pounds. And obviously we can't round this up because he wouldn't have enough money for it. So we'd have to round that down. So if we rounded that down, we would end up with 3 pounds of grapes. And there's our answer. So that concludes question 35. All right. We're almost there. 2 left to go. And of course, we get another graphing problem on the test where the lines didn't print properly. Love that for us. But we're going to make do. So, solve the system of inequalities graphically on the set of axes below. And we want to label the solution set S. All right. Well, we got our work cut out for us on this one. So, first things first, whenever we want to graph something that's a line, which we can tell these are going to be lines because there's no exponents or anything, is we want to get y by itself. So let's start with that. We'd first in this one want to subtract 3x from both sides, which would result in the inequality reading y is less than, and we want our x to be first, so we're going to say minus 3x plus 5. And then this other one, well, we typically want y to be on the left side, so let's add y to both sides. So that gives us y plus 1 is greater than or equal to 2x. Going to subtract 1 from both sides, which leads us to y is greater than or equal to 2x minus 1. So we've got these two inequalities now. They're both in slope-intercept form, so we can use our y-intercepts, and we could use our slopes. So for the first one, slope and y-intercept, our slope is -3, and our y-intercept is 5. For the second one, our slope is 2, and our y-intercept is -1. So let's start with the first one. Remember, we always start with our y-intercept, which in this case is 5. So we've got right up at 5. I can kind of see the lines here, trust me. And with a slope of -3, that means our rise over run is -3 over 1. So we're going down by 3 and right by 1. So let's do that. 1, 2, 3. 1. 1, 2, 3. 1. 1, 2, 3. 1. And we just repeat the process till we run out of room. I think that's where the line is. Good enough. We go up this way. Now, we need to be careful. When you're graphing an inequality, you can't just draw the line. You need to ask yourself, is it going to be a dotted line or a solid line? Well, when you have just less than or just equal to, or let me rephrase that, just less than or just greater than without the or equal to, you have to draw a dotted line. So that's what we're going to do. We're going to draw a dotted line through all those points that we plotted. My line could be better, but you're going to use a ruler, so yours is going to look better. And then, the second step, we need to shade. So, for y is less than, we need to ask ourselves, are we going to shade below the line, or are we going to shade above the line? And since it's less than, we're going to shade below. So the way I'm going to do it, I'm just going to draw my lines kind of like that to show that I am shading on this side. Your shading doesn't need to be super heavy, by the way, as long as it's visible and as long as you know what you're doing with it. And as long as it's, clear. This is a way that I recommend shading, doing it like in the opposite direction of the line, because it'll make the next step a little bit easier. All right, one line down, one to go. This next one, our y-intercept is -1, so we're going to put a point there. And our slope is 2, which is just the same thing as 2 over 1 if we're thinking in terms of rise over run. So that means we're going to go up 2, right 1. Up 2, right 1, and we repeat. And we go in the opposite direction as well until we run out of room. Now this time, we have y is greater than or equal to 2x minus 1. And since we have that or equal to, that means we can draw a solid line. So we draw our line through all our points here. Draw our arrows on the end. Oops, I almost forgot to label. This one is y is less than -3x plus 5. And this one is y is greater than or equal to 2x minus 1. And our shading, since we have greater than or equal to, that means we're going to shade above the line. So we do the same thing we did before, just I'm doing it in a slightly different direction. And the reason, as you can see as I'm doing this, is you can kind of see where the shading overlaps, because that's what we care about. Where the shading overlaps, that's the solution set to this system. It's where both of the inequalities are true. So that matters. So the fact that it's visible and actually has some way you can see it really makes a difference. Because you can kind of see this region here, they're all just going this way. This region here, they're all going this way. But in this region, they're going both ways. And as the question says, we want to label the solution set S. So we're going to, in this solution set area here, we're going to draw a nice big S. You can do whatever you need to do to make it visible. I'm making a bubble letter here so that it's really obvious. Whatever you need to do to make sure that S is visible. Artistic skills beyond belief, I know. All right. But unfortunately, we're still not done. Because there's a second part to this question, as there are for most part 3s. Is the point -5, 0 in the solution set? Well, let's find out. -5, 0, that means that our x value is -5, our y value is 0, So we're going 5 to the left. 1, 2, I can kind of see these lines. 1, 2, 3, 4, 5. And at 0, it's right there. So let's actually just label that point. Negative 5, comma, 0. And as we can see, it absolutely is in the solution set. So as long as you graph it, explain your answer, you could say, yes, point plotted above lies in solution set. Done. Your graph did your explaining for you because you plotted the point. That does it. That is enough. So point plotted above lies in solution set. We've got both of those inequalities graphed. We plotted that point. We labeled the solution set. And we're done. So that's what you would do when you want to graph a system of inequalities and find a solution. And with that, we are done with question 36. And we are going to move on to the final question on this Regents exam, question 37. And it looks like we're going to go just under 3 hours, which is perfect. All right, what do we got here? An ice cream shop, okay. An ice cream shop sells small and large sundaes. One day, 30 small sundaes and 50 large sundaes were sold for $420. Another day, 15 small sundaes and 35 large sundaes were sold for $270. Sales tax is included in all prices, so basically don't worry about it. If X is the cost of a small sundae and Y is the cost of a large sundae, write a system of equations to represent the situation. One thing I'm going to note here. This is the only part 4 question. This question is worth 6 points. So this is the most point-heavy question on the whole test. So let's just note, X is cost of a small sundae, and Y is the large sundae. So let's think about the information that we have here. 30 small sundaes and 50 large sundaes were sold for $420. Well, if X represents the cost of a small sundae, then that would mean we could do 30X to do 30 times the cost of a small one, plus 50Y, which would be 50 times the cost of a large one. And since it was sold for $420, that should equal 420. And then the second part, 15 small sundaes, so 15X, plus 35Y would equal 270. So that's our system of equations. It's just these numbers. We're basically just translating all of this information into math. So for the second part of this, Peyton thinks that small sundaes cost $2.75 and large sundaes cost $6.75. Is Peyton correct? Justify your answer. So we need to actually confirm if that works. Now, we are already going to determine the cost of a small sundae and a large sundae. So we got 2 options here. We could either just plug these values into one of these equations and see if it's true, or we can just do the third part of it, solve it, and just see if they're the same. I think it's better for us to do the first part first. So here's how we can prove if Peyton is correct or not. If they're saying that the small ones cost $2.75 and the large ones cost $6.75, well, let's see if it works. Let's take the bottom equation because they're smaller numbers. So we've got 15, and instead of X, I'm going to write 2.75 plus 35, and instead of Y, I'm going to write 675. And then let's just plug that in the calculator and see if it actually comes out to 270. Because if it doesn't, then Peyton's wrong. So 15, 2.75 plus 35, 6.75 comes to 277.5. So it's very close, but it is not correct. 277.5. So we did the math, we showed it, so Peyton is not correct. Don't write an exclamation point. Peyton is not correct. Good enough. So now we need to actually figure out what is the cost of a small sundae and a large sundae. So this is going to be a bit of a throwback here. We need to solve this system of equations. 50y equals 420, and we've got 15x plus 35y equals 270. So what we can do to solve a system of equations is you can actually take one of the equations and multiply it by something. So we're going to use what's called the method of elimination. I'm going to demonstrate it for you. I'm going to take this bottom equation. That's not supposed to be 3. That's supposed to be 35. I'm going to take this bottom equation and I'm going to multiply the whole thing by -2. And you're going to see why. So the top equation is not going to change. That's still going to be 30x plus 50y equals 420. And the bottom one, 15x times -2 is -30x. 35y times -2 is -70y. And 270 times -2 is going to give us -540. You can just do that in the calculator. So now we can add these two equations together. Basically just line things up and add all the like terms. So 420 plus -540, basically 420 minus 540, -120, 50y minus 70y gives us -20y. And then here's the fun part. 30x minus 30x, well, they cancel out, so don't need to write anything. And now we can solve this equation. -20y equals -120y. We just divide both sides by -20. So we get y is equal to -120 divided by -20. Let's do that here. 6. So y equals 6. So we now know that the cost of a large sundae is $6. So now we just need to use that to figure out the cost of a small one. And since we know the value of y now, I can rewrite one of these equations. I'll just use the second one. 15x plus 35, and instead of y, I'm going to write 6 equals 270. Now we just need to solve that equation. So we'll simplify first. 35 times 6. That is, I forgot to show it, that's 210. So we have 15x plus 210 equals 270. And then we just do the same thing. We subtract 210. We end up with 15x is equal to 270 minus 210 is 60. Divide both sides by 15. And we get x is equal to 60 divided by 15 is 4. So x equals 4, y equals 6. If If you really want to drive this home, you could write out the whole thing. Small sundae is $4, and a large sundae is $6. And we are officially done with this Regents exam. With the August 2022 Algebra 1 Regents. So that's it. We hit just about 3 hours. I think I didn't actually start working until a couple minutes after the live stream started, so I think I finished this in under 3 hours. So that's kind of to prove a point too, because if you do the whole test and you take your time and you go at literally the same pace I was going, even though I was explaining every single part of every question, you can still spend a lot of time on each of these questions. So with that in mind, I hope that at least some of you watched. One thing I will point out, this is the reference sheet that you're going to have on the back. It gives you a bunch of unit conversions, which might come in handy for certain questions. And remember, as I said, ready? Quadratic formula. There it is. It even has formulas for arithmetic sequences, geometric sequences. Don't worry about geometric series or any of these things, really. Little, very complicated formula for exponential growth and decay, but again, don't worry about that too much. So it gives you really what you need. You don't need the Pythagorean theorem either. So, again, hopefully you got something out of this. And that's it. I'm going to end the stream here. I'll see you all tomorrow for the last day of school. Good night.